Namaskar. Today we will discuss how to find the line integral. We are aware about the normal integration. For example, suppose I will have to integrate from 2 to 4 x square dx. Then I will have to find the integration of x square with respect to x, and it is x cube divided by 3 plus c, this constant of integration, and I will have to substitute the limit from 2 to 4. That means I will have to substitute the upper limit. Wherever there is x, I will have to substitute 4. Therefore it is 4 cube divided by 3 plus c, minus I will have to substitute the lower limit. Therefore it is 2 cube divided by 3 plus c. Correct? And this will be certain number. I will not calculate this right now, but you may calculate this. Now actually there is no need of consideration of this constant of integration c whenever there is finite integral, definite integral. The reason is that this c, when we substitute the upper limit, and this c when we substitute the lower limit, they cancels each other. This is c minus c, this will be 0, and just we can write it is 4 cube divided by 3 minus 2 cube divided by 3. Okay, and that will be a number. Now we are aware about the normal definite integral, finite integral. What do you mean by line integral? Suppose there is a function a bar, and if we think about the integration of this function from a, which is say for example 1, 0, 2 to b, say for example 3, 2, 2, then the integration a bar dot dl bar from a to b is known as line integral. Now what about dl bar? dl bar is line element. Let in Cartesian coordinate system dl bar is equal to dx I cap plus dy j cap plus dz k cap. Now with help of some function a bar, we will discuss how to calculate the line integral. Let a bar is equal to x square y I cap plus or minus 2y j cap. Now I have considered a bit simple function here because within the time limit we can calculate the line integral. Now the same idea can be used to calculate the line integral of any complicated function, but I will add one more term. It is say for example x, y, z, k cap. Okay. Therefore now we will integrate this a bar along a line from a to b. That means I will calculate the line integral of a bar dot dl bar. Okay, I will write that is equal to integration. I will have to write the point a, therefore it is 1, 0, 2. To point b, it is 3, 2, 2 of a bar, that is x square y I cap minus 2y j cap plus x y z k cap dot dl bar mean dx I cap plus dy j cap plus dz k cap. Okay, now that is equal. It is very simple. First of all, I will have to solve this dot product, and we are aware about the solution of dot product. This will remain as it is, integration from 1, 0, 2 to 3, 2, 2 of, if I take a product between these two, it will be x square y dx minus, it is minus 2y dy plus x y z dz. Correct? Now remember that the dot product is there, and therefore the resultant is the scalar, and we can integrate the scalar term only. Now here what we observe here, if you observe here the first term, there is dx only. Correct? And at that time there is no change in y. Whereas for the second term there is dy only, and for the third term there is dz only. Therefore instead of having the direct integration from 1, 0, 2 to 3, 2, 2, I will split this into 3 parts. I will integrate from 102 to 302. That means I will change the value of x only. And during this integration, dy is equal to 0, dz is equal to 0, and therefore there is no need to consider these two terms. Only I can write it is x square y dx minus, or actually it is plus. Then beginning from this point, it is 302. Now I will change the value of y from 0 to 2, and I will be integrating from 302 to 322. That means here I am changing only y. X remains constant, z remains constant, and therefore there is no need to consider the terms associated with dx and dz. Only I will consider the term minus 2y dy and plus. Again I will have to integrate from 3 to 2. Now I will have to change the value of z. Now actually in this case, as our point B is such that there is no change in z, here actually there is no need to integrate. But suppose there is change in z, then the third term will include where the x will constant, y will constant, and there will be change in z. And I will have to integrate the third term only, that is x, y, z, dz. Now if there is no change, then how to solve this particular term? To understand that, I have considered here the point where there is no change in z. I have considered the point where there is no change in z. But in general, if there is change in z, then what you will have to do? You will have to consider the third term where there is change in z only, and the term associated with dz is to be considered here. Now, what is the situation here? Here the integration is over dx. X changes from 1 to 3, but at that time y is equal to 0 and z is equal to 2. For the second term, I will have to integrate over y from 0 to 2, and at that time x is equal to 3 and z is equal to 2. And in this case, I will have to integrate over z from 2 to 2. At that time, x is equal to 3 and y is equal to 2. Correct? Now here, what happens? See. Now if I substitute y to be equal to 0 and z to be equal to 2, then this term will vanish in this case. Correct? In this case, this term will vanish. And therefore, it will be 0 dx from 1 to 3. Now if the function is such that there is no x is y is equal to 0, suppose the point is such that this is not 0, it is, say for example 2, okay, and it remains 2, and therefore we can say that, or it is 1, then here I will have to substitute 1. At that time I will have to substitute y to be 1, and I will have to integrate x square dx, correct, x square dx. But in this case, now we have selected the function and points in such a way that it is 0, therefore okay, fine, it is 0. Here what we will have to do? Plus, I will have to substitute x to be equal to 3, z to be equal to 2, but there are no x and z in this case, and therefore there is no need to substitute. Just I can write the integration from 0 to 2, because y is changing from 0 to 2, integration is over dy, and of minus 2y dy. If the function consists of x and z in the middle term, in this term, then you will have to substitute that x to be equal to 3 and z to be equal to 2 there, and you should have to calculate the value of the middle term of the function. In the third case, if I substitute x to be 3, y to be 2, then 3 into 2 into z, that is 6z, I will have to integrate from 2 to 2 over dz. Correct? 2 to 2 over dz. And therefore, here I can write the integration of 0 is there, and therefore it is 0, plus integration of minus 2y over dy is minus 2y square divided by 2 from 0 to 2, plus integration of 6z over dz is 6z square divided by 2, but from 2 to 2. Correct? Therefore, this will be equal to, now this 2 gets cancelled. If I substitute the upper limit, it is y square, it is minus 4, and if I substitute the lower limit, it is 0, and therefore there is no need to substitute that, and therefore it is minus 4. For the third, here I can say that it is 2 3s are 6, it is 3z square. But if I substitute upper limit, then z square means it is 2 square, it is 4, minus lower limit. The upper and lower limits are same, therefore the values are same, and 4 minus 4 will be 0, into 3 is 0, and therefore this term will be equal to 0, correct? And hence the value of integral will be minus 4. Now purposely I have considered the function and points in such a way that here the upper and lower limits are 0. That means for the initial point and for the final point, the z coordinate will not change. For the middle term, the integration was normal. For the first term, I have considered that though there is change in x from 1 to 3, the value of y to be 0. That means what happens if the y is to be substituted. And for the middle term, I have considered only 2y j cap. The reason is that there is no x and z, and therefore there is no meaning to substitute the values of x and z. But generally, if the function is such that you have to substitute, then you have to substitute the value like the first term. You can ignore the values like second term, and you need no calculation of integration like the third term. Therefore, all the possibilities are covered in this case. Most of the possibilities are covered in this case. Now as a homework, you may think about the line integral, calculation of line integral with, say, the function p bar is equal to 3x square y cube I cap plus x y square j cap minus z raised to 4 k cap from a point M, let it be 1, 2, 3, to the point N, let it be 3, 2, 6. Okay. Now try to find the line integral of this. That means try to find integration of p bar dot dl bar from M to N. This will be the homework for you. Thank you.